Hello, hello, morning guys. Yeah, so this is just me preparing some stuff. What I wanted to do is look again at MPC Forces. Um, the reason behind this is that if you just imagine you have screw connections or bolts and you would model them as rigid connections with an MPC, you would like to know what force is transferred. And yeah, if remember that correctly, it was not that easy to get the results with a one-click solution, but I'm not 100% sure about this. So I try to model something simple and yeah, go on from there. Let's see what this will come up with. The first thing I will do is turn to my GitHub and get a script for 2D analysis because I think this will save me a little bit of work. So 2D analysis, I will just copy the code. And you can also, if that's something which interests you, you can copy that from my GitHub too. So basically what it does, it creates properties, materials, and load collectors and stuff like that so that I don't have to create that manually. Yeah, so now with this being done, I think I can now turn to the geometric modeling. And by the way, this is just me preparing some stuff, so it's nothing serious. So if you have any questions or so, yeah, just drop them in the chat, and I see if I can answer them on the fly, or I will note them down and make a video maybe later. Now, geometric modeling here. I would say I would go with something real simple. So let's do a sketch. Let's create a rectangular. Let's use this plane. And let's just create a simple rectangular. 200 by 200 seems about right. And yeah, so now let's maybe create a hole here. So I'd like to do that here. Maybe somewhere here. Let's also make that, oh, let's make that defined. Okay, now I think I just have a circle, right? Now I will just split something with a line. Target would be the surface. I want to use that line, split that. I think that did not work. Oh man, it's this again. It's showing up on the different screen. I think I have to restart the thing here, the Hypermesh instance, because yeah, it's a bit tedious. Yeah, so let me just get that finished here. So let's try the split operation again. So surf, no, lines. Target would be this, lines would be this. Extend trimmer, that's okay. Split. It doesn't say anything down here, but I don't seem to have it split, have I? I can delete this. Ah, okay, it was just overlaying. Okay, so I have now a plate with a hole, and I could now, for example, duplicate this and paste it in here. And maybe we will just move that by wait, what? Wait, how was that again? So move, I want to select this coordinate system first and move only the coordinate system. Was it shift? Yeah, shift. So I can move it here. Now I can rotate like this and then move it up a bit. Alright, so that's pretty simple. So I have two plates here. Maybe let's do different colors and name them. And yeah, so that's about it. Let's assign them properties. So let's use the design property I have already created. Now let's also check the thickness. 1. Well, maybe let's do 2. Okay, now let's generate a 2D mesh. So I would like to generate those meshes or this mesh on those surfaces. And I want to have this made sure that it is element organization surface component. So that has to be done here. Yeah. Now the thing is 10 would be I think too big as a mesh size. Let's do with 2. Let's see how it goes. Yeah, I think that's fine. Yeah, we are not looking into detailed stress results here, but I would like to have some notes. Yeah, to just make it a little bit more realistic with the outputs I think I will get with this model. Now, the next thing I will do is create a bolt connection with a rigid. So, to be honest, the correct way would be to model a rigid here and a rigid down here, and then connect those two with a bolt, because the bolt then has a stiffness. But I will not do that. Maybe in a future instance I will do that. But now just the most simple approach you could think of, and this is to be just a rigid here in the middle. And because I don't really I don't constrain anything on there. It's just to connect it. But I think I would. Yeah, I will use a rigid just for simplification, not a RBE3. So we could talk about the difference between RBE3 and RBE2 here, but I will just use an RBE2, so a rigid. So this means motion between the slave nodes is prevented. Makes it a little bit more stable too. So it would be the same thing as you would think of having a bolt which is tightly fitted there and glued to all of the sides, right? So this would be the metaphoric, yeah, real case use scenario. All right, so rigid is here, and then you have to select nodes. First of all, it wants to have the independence, so this would be the master node. You could also calculate this, what we would do here, and now it's on me to select the nodes here. Oh, sorry, I have to restart that because all my menus pop up on the different screen. Now I even cannot close this one. Man, that's frustrating. Save as Hypermesh. Plate simple rigid. Okay, let me close Hypermesh and reopen it. I think I'm on the 2023 version right now. Yeah. But yeah, I think this is also perfectly fine for the 2024. All right. Now we have that. Well, let's hope that the rigids work here. So again, calculate nodes, select this one, go to a few that we would like, and then select the circle as a mode of selection. It seems that it is not perfectly aligned. Why that? Because it's just a few. Oh, strange. Maybe that's also perspective. I'm not sure about this. But either way, I think we will be fine. Let's see if we are. Looks fine to me. No, it doesn't. So with shift, you can deselect the nodes again. So that's what I did here. Now I selected all the slave nodes, or yeah, so the dependent nodes. And we can click OK here. And you see the RBE2 is created. So that would be our MPC here. And now I think we can go to model the boundary conditions. So I have two load collectors here. The first one is the SPC, and I always start with the SPC. So I would like to hold this plate into place. So we will apply a do not move constraint here. And again, we will just select the nodes. Yeah, so that's one line of nodes, and you see by default all of the degrees of freedom are checked. So that means they are active, and that means this side is completely fixed in all directions. All right. Now let's turn up to the loads, make current, and apply a force here. And again, selection, something like this. All right, 101 nodes. So what would be a force we would like to apply there? Maybe -5, so that's totaling of 500 newtons, something like this. Maybe just to be precise here, let's just take away one node. Maybe not one at the outside, but just one here. So that we have 100 nodes, and 5 times 100 is 500 newtons, which will get applied here. So the direction should be -x, so not 1, so 1, 0, 0 instead of 0, 0, 1. Create. All right. So we have that. So this side is being pulled to the right. On this side, I have it fixed in place, and I have a connection here. So it's pretty simple. Now, in order to have the MPC forces, because I would like to validate that the force applied here is being transferred here, and ultimately also appears here. So this is more or less a simple version of a model check you could or should do on your analysis model. So in here it would be pretty trivial because it's just one load path. But just imagine you having multiple locations with multiple constraints on there, multiple connections, and then suddenly it's not so clear how much load is transferred where. And so this is a good check to just make sure that what you think is really happening. So the most important thing is to check the SPC forces. So that would be the constraints here. That means you put 500 newtons here, so you expect that there's 500 newtons here. And yeah, and then again, MPC forces check would be to check if the load is also transferred via this connection here. So I don't think there will be too much trouble with that, but yeah, let's see. All right, I think the load step should be defined already as a linear static load step. I have SPC and loads already assigned. That's all being done by the script. And now let's see if we have to get some output for this. I don't know if it's been done here or with a separate card. Let's just check. Do I have something like MPC force? No. Yes, MPC forces. Now here also the format is important. I think the best way forward, because I have the scripting in mind, is to put that out as a text file, and I think Opti is the right format here. So I think HD5 would also be a great option, especially if you have big files, but I think that's something which we can talk about later. Now yeah. Alex, you're looking forward to scripting? Yeah, me too. Let's see how it goes. Well, the scripting will be, I think, something with Python, right? So it will be, I think, pretty easy. I hope. But yeah, let's see. Now, Opti would get us text info, and what I would suspect is that I have for each node, I would get something like a force acting on this node, and I think then again, I think I have to then see or get the component of each side, something like this. Yeah, good morning, by the way. Yeah, it's 8 o'clock in Germany, or 8:20? Yeah, 29. So, yeah, Saturday mornings. Yeah, all right. So, yeah, I will think that we get a text file here with this opti. And we also have the SPC forces, hopefully here. SPCF. And here I think the format could be just with the H3D, but let's also choose opti here. Because maybe we will put that, what I tried to do with the scripting then later on, to something like a I don't know, like a collection of validation scripts or so, something like this. I think this is really needed. But not getting ahead of myself here, but I'm just in my professional work life, I'm always a bit confused about how easy this is with for example ANSYS, because you can just get that pretty easily, those results or those kind of results. And with Hypermesh, I just looked briefly at it, but I thought that it would not be possible to do it without scripting. But we will see. That's why this is a preparation stream. It's not that's not fully cooked, so it's just yeah, it's just a yeah, preparation stream. And some things may go wrong, and then we will fix it and stuff like that. So this is perfectly normal. Yeah. All right, now I think load step would be fine. SPC Forces, MPC Forces is checked as an output, so I think we will get some files there. So yeah, let's just give it a shot, right? Now let's just make a new folder here. Run one. Just export that and run it in the background. And then we will see what files we will be getting. So the analyze is finished. By the way, did not check the aspect ratio, that the thickness, how it relates. Let's quickly do that. Yeah, I think that's okay, right? And I think 500 newtons is not too much, so that's 50 kilos. That's okay. All right, then I will say it's time to switch over to some scripting. In the background, I will transfer some files. So we have from the run one, I will just see if I don't have any optis. Why? I think. Huh. So just see, this is what we will be getting. Right? So we have the FEM file, the H3D file. Ah, MPCF, that should be the opti file, right? Let's check that. Second autumn window. Okay. So it looks like this. As a text file, we can definitely work with that. But you see, this is where I have the problem. Maybe that's also the reason why the stream is happening, right? So just imagine I would be a typical normal structural engineer. I had run my model here, and maybe I would like to sorry, wait a second. I have to get some things sorted here. So this should be a hyperview. Okay, I think now it's working. Sorry, again, that monitor issue. Now, I would like to have the displacement, for example. I can see it's showing 7 millimeters. Okay, that's fine. Interestingly, it's moving down. Yeah, because I have no support. Yeah, that makes sense. It's always good to check your intuition. It's not a tension case, because you have a tension, but then you have a lever. That's a lever, and that's bending it down. So this is exactly what's happening here. Let me synchronize this. So just think of it, pulling it here will lead to it bending down. And that's why you have this much of a displacement. Because 7 millimeters, pretty much for 50 kilos. In a pure tension, case, it would be far less. So just mentioning that. So now, yeah, just think about, yeah, you have the element stresses. Maybe I should have also inputted the H3D as an option. Yeah, let's maybe do that, just that you see where the problem is coming from. So if you just would like would do something like this, and you did not select the Opti, but you did not select anything as a format, normally I would suspect that this is being outputted in the H3D file. So that means if I just run this again, and let's just maybe do that as a new folder, run default. Let's just let's just get another view here. I could specify it also as H3D, but I think the default case is H3D. Sorry, that's still Hypermesh. So run, no, not command, run default. So if I open the H3D file here, I would suspect something that I have something like SPCF or MPC Forces. Yeah. So you have SPC Forces here in the H3D file, right? And you can see that you have 122. Yeah, it should be at one edge, right? So this is here. But again, in order to have the whole thing, you would have to sum it up, right? So at least that's my understanding for it. So you could go to a table, then, for example, put in those nodes and see, okay, the SPC force here is 120 newtons. And then you go to the next node, then you have also 120 newtons. No, sorry, 12 newtons. I'm stupid. I just was thinking about how on earth would that match if the sum has to be something about 500, right? So that doesn't make sense. Yeah, so 12 is a lot better. Yeah, so you could do something like select all the nodes, apply it, and then I have selected the wrong one. Sorry. So let's clear the table again. And yeah, it doesn't matter if we have too much. But we have something like this, and you would have to sum it up. I think it's a workable solution, but it's not that kind of great. So for one screw connection, that would be fine, right? So screw connection would would work like the same. So instead of SPC forces, you would have the the MPC forces, right? And now you could have it here. And you could also create sets and stuff like that. And I think also there's a results math, and then you could maybe do something like a sum or so. Yeah, that for sure there's something like with an expression and stuff like that. So that's maybe one thing I overlooked, or there's maybe this advanced query, something which could work. Yeah, but it's not out of the box that you could, for example, if I just could speak freely, right? I would like to have something which maybe now it does. That would be pretty embarrassing. But if I just click on this element, I would like to have the sum of the, yeah, I don't know how to do this, but yeah, just to think about us from a structural point of view, you would like to have the sum of all those. And I don't see a thing which does it here. So not sure if I'm missing it. Maybe with the vector, but still, I mean, you have it here, right? You can see it. You can see the forces, but summing them up is nothing which I can find being done easily. And so that's why the scripting comes into place. So coming back to the scripting, let's just think about what files we would use. I think those 3 files would be enough. Let's just copy that into data and let's turn to the scripting. Now, what I think would be the best way forward is to have something like a reader which reads a file like this and reads just the X, Y, and Z force components here. Yeah. By the way, that's strange, right? Why the hell is this? So I already see me doing something like error catching and stuff like that, because this is not, it's not comma separated, so it's not easily scriptable. So you have to split by space. But then again, you have something like this, and that's not really good, because then maybe you have to switch from separation by space. You have to switch to a defined length. That could also be a good thing to just have. Yeah, just those characters belong to the first cell, then those characters to the next one. Yeah, but you have to be careful, very careful about this. Not that you have something like that. So Alex, you say I try find attached, then only select the elements we need. Yeah. Yeah. But the thing is, how do you do the sum? Just think about, I mean, you can do it with the table, but I think that's so, I don't know. You could do something like this. Nodes, and I think then attached. Is there attached here? By attached? Yeah, but I see what you mean. So you could think about selecting, for example, the element and say attached nodes, and then you would select all the nodes here. But yeah, and then you would have to deselect it. But the thing is, you still have to go to table, select all those nodes, then copy that into an Excel and do the sum of it. And I think, I mean, for checking one interface, that's not that of a big of a problem, right? But I think, let's just imagine that you would like to have that for multiple screws or for multiple connections. And like, I mean, really many, many connections, like 50 or 100. You don't want to do that manually. You would like to have a script which goes just through them all and calculates those for you, and then give you just a short summary. And maybe there's something like that. That's maybe a thing. But I think it's also a good exercise to just do a little bit of scripting. Yeah, yeah, sets. Then you can select by sets, but still you have to do the table by sets sum, right? I mean, you could maybe do that then with the results bar here. Sorry, maybe that's a thing here. So MPC and then the magnitude. I don't really know if the magnitude is correct, because you would like to sum it up independently and then maybe. But yeah, you could also do a X whatever. And but still, you don't see something like a set. Yeah. But yeah, I'm happy to learn about how it's done. Really. So I just came up that could be a good exercise to do a bit of scripting. And I see the value of having something like a tool which just scans through a file like this. And yeah. By the way, it's not even that simple, to be honest. Um, so let's just think about, or I just share my thoughts about how to do this. You would scan through this file, and all you're getting is node IDs and forces values. So you don't have any idea of what element these belong to, right? So you don't have any idea about if it's a node up here, if it's a node down here. So that's all in the dark. You would have to guess that, and I think the easiest way to guess that is by looking in the .fem file. So first of all, we would have to have something like a FEM file reader, which selects or just reads in every node. So that's the grid values, and then all the elements, and just connects them. So more or less. So yeah, that's a bit. Yeah, I mean, I see why it's so much easier to do it with the sets. But let's just imagine this is all we got. We have to do it like this. Um, yeah, sure. From time to time, I do live streams. Thank you for being here. Yeah. So I just thought it would be yeah. To be honest, I did not plan to have too much time spent to this today, but maybe get something kickstarted for the future days and see. Yeah. But yeah, always appreciated you being here. And yeah, if you have any questions about something Hypermesh related or script related, we can also go into this one. It's just something I like to do here. So again, coming back, so there somewhere we have our widgets. And the widgets, let me see, how are they defined here? So we have the C quad elements, and I would suspect there's somewhere some different element. So we have C quad elements, we have the trier elements, and then we have the RBE elements. Oh, okay, it's far easier. It's far easier. Good morning. It's far easier. So with the RB2 element, we get the following. We get, I think, the element ID, and then we get all the node IDs associated to it. So this is a good thing. So it's not that much of a struggle to get all the node IDs belonging to one particular RBE element. Because if we would have a second RBE element, that would just come up here. So data we would like to extract from the FEM file would be the RB2s. And yeah, let's maybe just do a little, let's just maybe do a little script picture here, that we are all on the same page. Now we have the RBE2, and this RBE2 then has an ID, and then it has nodes, or node IDs. The thing is, a node can belong to an element, right? So an element can reference a node. And I think that the component is just on the element. So the thing why this is important, we have our two plates, right? Something like this. And I will not go into something about checking that all the nodes should be in one plane or so, or on one radius. You could do something with geometric calculations to just isolate those nodes versus those nodes. I would just assume those are different components. That's the easiest way. So an element here would reference to a node, right? So we have an element here would reference to a node. This node is then somewhere here in the RBE2. and it also has this linkage to the component. So I know I could select this node IDs to be in separated components. Or let's make it a little bit even better. So we don't have that, but what we would like would be a list of component ID to, so this would be a dictionary to node IDs. And that's also a list. So let's just think about a component ID for our case here. We would have a component ID 1, and then we have several values for the nodes. And then we have another component ID, something like this. And then we have another list of X, Y, Z. So those are node IDs, to be honest. It's not really a good thing to call them ID1, ID2, and so on. But in order to make this, so this is our target. This is the target. But in order to make this, first of all, we have to read in RB2s to get this structure. But then also we have to read in all these to get this structure. So it's not that easy, or not that simple. It's not really difficult to do it, but there's a lot of things going into it. There's a lot of things going into it, and we have to account for that. Because I think there's no, I mean, it would be the easiest thing to have grids with a component, but that's just not how it is. So we have, yeah, we have, I think this is the component ID, right? So if the C quad, that's the element ID, then I think this is the component ID, and then we have the elements belonging to this element, the node IDs. And yeah, I mean, I hate to say it, but I just think about how to do that efficiently. So my mind is running right now, because it's not a problem to do it for file size like this, but just imagine you have billions of nodes, then this will get really interesting. So, but I don't see any 2s here, so that's a bit strange. I would suspect I would have C2s. So I have just seen 1s here. So it's a bit strange. So because there should be 2s, a lot of 2s here. So I'm not sure if this is really the component ID. If that's not the case, maybe we have to change our structure too. Or maybe I'm just not seeing it. Let's think about how could it be differently. So we have something here about P shell data, that's property, that's component. So that's a good thing. So but it's all commented out. Hypermesh name and caller information. Yeah, that's not really a thing. Yeah, let's just look it up. Let's just look it up. So I just look up for C-Quad 4 and see if I can find some card data on this one. Ah, it's property ID. It's a property element. And so you have C-Quad as a thing here, then you have element ID, and then you have property ID. So the component information is not really there. So you just have the property ID. Now you could force something about having different properties IDs for different parts, but this is rather soon getting a little bit too, yeah, what should I say? It's not that good. But I don't think we have anything other than that. So let's think about it again. So I need the component information solely because I would like to differentiate between the one group of nodes and the other group of nodes. Yeah. Is there any other way around it? I mean, if there could be, there could well be. So we have, for example, geometric modeling. You could just do something about which nodes are tightly close together. You could do something like a clustering approach. Clustering approach would definitely work, but yeah, not sure. That's all not too easy, to be honest. Clustering approach would work. I know that, but what else could work? So if it's not a clustering, if we don't do a clustering approach, then we have to get the component ID. And if we want to get the component ID, we don't have this connection right here. This is missing. Let me erase it. So this is not there. Because there's an ugly property in between. And this property has nothing to do with the component. So we just have that. So that's stupid. That's not good, not good. There's nothing here too, right? Yeah. Property. Property, then grid point identifications, feather, material coordinate system identifier. No, there's nothing there. Nothing there. All right. So in order to be able to separate the nodes, we would have to have the component IDs. And so we would have to have, we would force that on the user to have different properties, even if they are the same shells. That's not good. But I think I will stay with that for now. Because I think we will be getting nowhere if we would do the clustering as well. Because the clustering alone would require to know something about the number of nodes or how they are in space. So that's also no, it's not good. All right. Yeah, let's just stay with the uncertainty here and just imagine that we have different design properties. So we would have to have different IDs here. Let's just model this way. And we could also do something like a script on TCL, which converts a arbitrary model to have something with different properties. By just looking at the components and duplicating the properties and assigning them to that it will be ensured that every component has a different property. Okay, now let's do that. We have plate and plate 2, but the properties we have is just one. That's the design property. Now let's call that property yeah, prop 1. Cannot select all. Prop 1. And let's just duplicate this. Yes, duplicate. And let's call it prop 2. Let's also give it different colors. It's always a good idea. And let's see that the plate 2 has a property too. Yeah, that will make our life much easier. Now let's run this one again, but I have to change the load step again because I changed it to H3D and we want to have the OP2, OPT. Now run that again. Let's run one. Alrighty, we have that. Then I think I have to copy the data again. So I think, yeah, let's just copy it once more. Alright, now let's read that in, and you can see already you have the 2's here, and hopefully you will also have the 1's here. Yeah, so you see 1 and 2. Alright, now I think we can finally get to the scripting. Yeah, and as I have started to use the Copilot and things like this, we will make heavy use of this here. Because I keep forgetting all those simple stuffs because yeah, I'm just constantly switching between Java and Python all the time, and yeah, sometimes it gets in my head. Now let's just think about what to do here. First of all, we would have to have a better folder structure. So let's do a folder with MPC Forces validator or something like that. No, let's call it differently. Post validators. No, that's also something not good. How to call that? So what I wanted to do is something with SPC and MPC Forces. So yeah, it's just a working title. SPC Forces tools. Now I will create another folder called reader. Let's do the main in here. Let's create a file init.py here. And we would like to have a FAM. Yeah, let's maybe FM file reader. No, that's not a good name. Model reader. Model readers. Let's make it plural. Okay, now let's have a class called FAM file reader, something like that. Now let's have first a is not good. It's not too bad actually. Yeah, but let's just start with having some variables. File name, no, file path. It's none. Then what would we like to have? We want to have something like nodes, which is a list, and that would be an empty list at the beginning. Elements. We don't care about the materials right now, so we would have to something like node to property ID. This means that we also have to have properties. Yeah, that's also a list. That would be a string. So we have a file path, then we have node IDs. Yeah, let's just make that simple. So we don't have a data structure for nodes and elements, but just call that nodes and elements, but it's actually the IDs. Nodes and elements. The properties, those are all lists, and then we have node to property ID. I think this is what we ultimately want, but we have different things. We would want to have something like the RB2 ID elements, because we want to have that separately. Yeah. So RBE2 or widget. Let's call it widget. Widget elements. That's also a list. But a list of a certain type. I think we should definitely use our own data structure here. So let's create another folder with data structure. And let's create a new file called widget. Yeah. So let's create a class called RBE2. So normally I would also have something like a class widget or class MPC. That would be better. Yeah, let's just use this. This one would then extend MPC. So does that make any sense? So we would like to do that with ID, nodes, DOFs, and coefficients. Yeah, to be honest, I don't care about much of the coefficients and on the DOFs right now. So I would like to do just this. And we have the string representation. Yeah. Yeah. Is that not extends? Ah, it's other. No. What the hell am I doing? Is that something like so? Keep forgetting how to do this. Yeah, it's not extends. All right, so this is an MPC. The RB2 is one of the MPCs, and I think, yeah, it will work the same, but we would like to have some method here. And that would be def. Where do I do the pre-processing here? That's the question. The pre-processing would be that I take data from here. So no, not from here, from the FEM file. So the FEM file, just think about this line here. Grids. Think about this file lines. So we would like to have something, this is the ID of it, and then those are the nodes, and those are the coefficients, something like this. I don't know if there's something like more to this, but we would have to look into the card information on the internet to get that, but pretty sure that those are the node IDs until here, and this is the element ID. This is also interesting. HM comp ID 114. Is this the location of the element, of the RB2 element? Yeah, okay. And also maybe this is also something to do. That maybe also be a special case later on. Could be. Okay, now let's just think about this line. If we pre-process this line and we have to get this into data that will be able to generate a RB2 element. So the init would be, you would have to get the ID, the reference node. Ooh, I have to look that. I have to look that up. It's maybe not just the element ID, but also the reference node. That's a good thing here. So let's just look for RBE2. Is it maybe also here again? No. So we are in the, I don't know what this is, sorry, but RBE2, this one. So element ID, then we have, what is this? GN, grid point, which all 6 independent degrees of freedom for the elements are assigned. Okay, so this is actually the reference node. Then we have CM, component number of the dependent degrees of freedom in the global coordinate system. Up to 6 unique digits. See that? All right, so this is the element ID. This is the reference node. It's also created last. And then you have the 1, 2, 3, 4, 5, 6. That means all of the DOFs. Okay, so that's also good. So we would have the reference node. Still using this one, right? Yeah, I have to do this. The DOFs, so maybe we can do that. Sorry, that would go after the nodes. And the coefficients. No, the coefficients I don't need. Okay. Something like this. Now, we would have to do the creation of this element like so. I think that's all fine. Just thinking about what else could there be to input here as a method. What would we like to have in a class like this, right? So maybe we would also like to have an initialization with just the string data from the .fem file, but on the other hand, I think that's more a reader thing. That should be more in the reader methods. So I'm not really sure where to put this right now, but I think I will just leave it here like it is, and then move on with the model reader. So I think I have now a data structure where I can create RB2 elements. So that's fine. Okay, do we need something else? So we have the file path, we have the nodes, the elements, the properties, the rigid elements, and the node to property ID. Node to property. If I have node to property, I'm done with here, because if I get this data, I know how to sort my MPC forces here. Because I can then go with this node ID, I can then go into this direct dictionary and see which property this is belonging to. I mean, really, it's such a shame that there is nothing about a component ID here. Maybe that's also not the best thing, but not too far away from having those. But there would be so much less struggle to if we have just a component ID. So Alex, you wrote, from nodes of RBE2 block of text, you might have to find the nodes occurring on the line starting with C quad. Yes, or C trier. Once it is found on that line at a particular position, the component ID. Yeah, exactly. That's what I'm doing. The problem now just is that it's not really the component ID I find with the C quads and C triers. So this is the ID I'm looking then for, but this is the property ID. And initially I just had the same property ID assigned to both components, so we had just ones overall. But now we have ones and twos. Yeah, exactly. So this is what I'm aiming for. But then if I have this data, I can then go and insert or just look up a node here and get the property back, or the component ID back, more or less. So I would just say that property and component IDs are the same here. And then again, I have to do this for all RBE2 elements. So later on, just think about it like this. For every rigid elements, go to every node which is attached to it and check the components or the component IDs and sort them. So the rigid element then, now coming back here, should have something like component to nodes. And that's a dictionary. Because later I can then get to every MPC and calculate the forces, right? So yeah, this will come into place pretty soon. This is just an empty placeholder, so it's just initializing a dictionary by on creation. But later on we have to fill that. And I think we will maybe do a method here for this one. No, I don't want to do that. Why are you doing that? How to do this? Yeah. So sort nodes by components. So for every node here, for E coefficient in the enumerate self coefficients, that doesn't make any sense. I don't have coefficients. Why is it still using coefficients? Oh, my Vim skills are rusty. Okay, forget about the coefficients. And I have to have something like something like this here. Node to property, something like this. All right, so it was not really helpful. Let's try that again. So node to property. Let's just also call it rather property. And that would be property to nodes. Node to property. So that makes sense now. So for node and nodes, property is exactly that. If property not there, then create it with an empty list, and if not, and yeah, after that, it just appends it here. Yes. Could that be the case that we would have duplicated node IDs here? Could that be the thing? And we have to make sure that, yeah, let's make it sure here too. Let's make it sure that we don't add duplicates. Yes, if that's not in there, then just append it. So that makes sense. All right, now we have a thing which sorts the nodes by property once we have this thing. And if we have that, we can then something, I know it's not the right position to do this, but let's just keep it for here right now. Calculate forces by property. So what should we here have something here? It would be node to force, which is a dict. So forces is a dictionary. Now for property ID nodes and property to nodes. So property to nodes for property ID nodes. Yeah. Forces is 0, and then it sums it up. Not sure if I like that. Because that would imply that we have just a singular force, and that's not right. We have 3 components. So the forces would be then a list, or it would be... So we have to do this differently. So force... Let's just make it real dumb here. So force x equals that, y, and z. Yeah, we could have... Yeah, no, we don't want the moments right now. And then let's do the summing. Yeah, let's make it real stupid here, but it works. Then we return forces. So this is the sum of the components. So let's maybe just back off a little bit to just have it right here, that we don't miss anything. So we would have to have 3 of those columns, right? Then we know which kind of properties those grids belong to. You can see it also here, right? So the 400 range is just meshing wise, and this is 1 of the components. So this is all 1, and those are all 2s. So what it is doing then, just maybe do that with an Excel, because we have to validate it later on anyway. Let's maybe just do that here. I will just calculate the sum of this. So if I just put that into Excel, right, so something like this. So what we are aiming for is something like this. So this is what we expect, right? So zeros and 500, right? So this is exactly what we want to validate. But yeah, this isn't a simple example, right? So this would be a solution, done, happy, go home and sleep, right? But now, if we have 100 or 200 or 500 of those connections, and we would not even know that those are the right nodes which are just belonging to one side of the connection, then it would be rather difficult to do this by hand. And this is what I try to do here. So we just validated what's going on, or what we would like to have as a result from the FE model, so that's all good. And so we would see, or we would think what is being here returned would be something like a list of 500, 0, 0, right? Or to be honest, no, not really. It would be a dictionary of 1, and then this list, and then we have maybe a 2 with minus 500, or the other way around, right? Something like this. This is what we would see, or would like to see. Let's see how it does. Yeah, so this would be then set. Now we can go back to the model reader and finally work on the importing things here. So, okay, file path is correct. So let's just do that. Let's just initialize all the stuff again. That would make sense. Then we would like to have a def read. Yeah. Yeah, also not so bad. Let's make it let's make this something like a file content. Yeah, something like this. And then let's read in the thing here. So we've opened the file, and I always hate that so much. It doesn't specify an encoding. Why not? As files, I have content, blah blah blah. Read. Yeah. Now we have different methods maybe to get different parts of the thing here. Yeah, get nodes makes sense. Let's do something different. Get elements. Get properties. Rigid elements. That also makes sense. Yeah, that's not really a get, but it's rather a build. But it should be done maybe, and also in one of the methods above. So let's start simple. Let's do the get nodes. So what I want to do is for line in self content, if it starts with grid, then add the node ID to the list. So let's see what it comes up with. With pass. All right. Okay, for line and line content, if line starts with grid. So now let's think about what this means. So we would be somewhere here. It starts with grid. Then we would like to get a second thing. Split the line by spaces and get a second item, and this would be the integer for the, yeah, that would be the integer for the node. So line equals line strip, yeah, that makes sense. And then I don't know if how I did that always, because to replace the multiple strings, I always fuck that up. So I have to see how it's done. Let's see if Copilot is smart enough to get this. Replace multiple strings with one and split by it. All right, line replace string with that, and then once again. Yeah, but no, that cannot be the case. There's definitely something. There's definitely something better. I just cannot think about it. Let me see. Let me see. I mean, I know the \s plus for Java, but that doesn't help. But does this work? Does it work with just a single thing? I mean, if this works, that would be the best thing, but I'm not 100% sure if this works. Something like this. But we can try that, right? So why not? New terminal. Let's just do something like Python. Let's define a string. Test equals grid. And then a few spaces, then an ID, and then something more. Now let's see. Test, replace. Ah, see, it didn't work. It just replaced every of the spaces with a separation, and this is not really good. No, that's not good. So maybe this one. Yeah, it's just works as intended, but it's not what we want. We want to have just one singular separation thing. Let me just quickly Google that. There's yeah, I remember now. There's this package called re, and then you can do something like line.sub. But this is a regex. What is it? No, it's not a regex, because regex are no-go. So I think this should work. So import. Let's do it like here. Import re, and then print re.sub, and then \s plus. So that's the same thing as in Java, and then something like this, right? And then we have to give in also the test, right? So something like this, right? Yes. See, that's exactly what I'm talking about. It's just one separation sign between grid and the ID. So that works. And now we can do a split. And then we have the node ID with the first one. Yeah, just like that. So Alex, what I think the test split with the space, the single space, will not work because yeah, let's test it. Let's just do test.split. I did not change it, right? So just with that. You see, it's this one. So the first would be just an empty space. So if you just, that's the problem, because you have multiple of those spaces. And if you have just replace one space with empty, something like this, then this doesn't work too, because it just removes one of those. And you don't know how many there are, because it depends on how long this character is, or how many characters there are in this node identifier. So it has different amounts of spaces to separate this. And that's why this method more or less works pretty good, because it replaces all spaces with one singular instance of a separation sign like this. How's it called even? Is it colon? No, it's colon. Colon is the... Yeah, it's this one, right? That's the colon. Yeah, no, I'm not sure how this is called. Yeah, but you get it, right? So it's you try to remove all the spaces and then put just one singular separation sign here. And yeah, then you can split it and then you know exactly that the second one is a node ID. All right, so I think this is then done. So, and also don't mind me that I'm just doing nothing about the documentation and stuff like that. That's for a future thing, but right now it's just a thing. Now let's see what we have here. Element keywords. Yeah. So what we would like to do is see tria, see quad for right now. Tetra, penta, hexa can also be a good thing for later on. So we will leave them here. So can I do something like a final? No. Okay. So element keywords. This is a variable which should not be changed. So I'm not sure how to do this, but yeah. So this is fixed. Now I can go same thing here for line and yeah for keyword. Yeah, that's not a good thing. That is bad code. That is really bad code. Because it would loop through every line in the file content in the FEM file. And then it would loop additionally through every keyword in the element keywords. And so that's not a good thing. But on the other hand, I don't think if I don't know if my implementer or my thought in my head is even better, because I would just check if the keyword is in the list of keywords. So more or less, this is maybe the same thing. That's maybe the same thing. Yeah, let's just leave it like that. We are not really considering performance right now to be an issue. So keyword in elements, if line starts with keywords, so that means it's an element. Oh, but then we have to have maybe different yeah. We have to have different oh man, we have to have different ways of doing imports. But actually, I'm not sure what. So for quad element, you have 4 nodes, but that's just C quad 4. But for C tria 3, you would have 3 nodes. Yeah. Okay. So there's multiple ways of how we could do that. Element keywords to number nodes. So for example, if C tria 3 would be then a 3, then we have C quad would be a 4, and the others we will just leave it for now, because then we can redefine this method. So keyword is then this one. So number of nodes. I always can hear the linter going crazy if I do something like a camel case style here. So keyword. So let's call it differently. Element keyword. Yeah, I like to be a bit more explicit here. So if that starts with element keyword, then we have our splitting again. And now it gets interesting. What we would like to do is to have, I really don't care about the elements here, but it's more like I would like to have element to nodes. Don't have that right now. So element to nodes. Yeah, I think that's more or less and that would be a dictionary. because that's what I care about later on. Because I would like to have, but to be honest, it's rather different, right? I want to have nodes to elements. No, to be honest, it's even more different. I would like to have nodes to property. So I think we can get rid of all this. Yeah, let's get rid of it. So rigid elements we would like to have, and elements we don't like. Something like this. Maybe we can do it like so. Because, yeah. So if it starts with that, now we have that. So we would like to have the element ID. That's the first, is it? So that's the first. Yeah, 0 first. Then we have also the property ID. We can also get that straight here. Yeah, that's the next one. And then nodes is all the rest. So even I don't really have to have the number of nodes, right? So by the way, I can think of something here also being nasty in the future. If we have a hex element or something with more than 8 nodes or so, it will have another line with a plus beginning at the beginning. Something like with the RB2. With the RB2 you can see it, and you will have something like this here too. So we definitely would like to have something which reads in more than just one line. Maybe we can make something like a pre-processing of the file content. To do something like if a line begins with a plus, just remove the new line character and the plus altogether. No, that also doesn't work. Yeah, that's a thing for future. So that's not a thing we should be dealing with today. So nodes is that, so we really don't need this. But maybe later we need this. Now we have the nodes. No, that's not correct. For nodes, in nodes, yes. If that's not in the keys, then node to property, node as a key, property ID as a value. So this is filling this thing. We even don't need the element ID at all. Maybe later we need something like this. But the get elements now also more or less does this. So to be honest, let's rename that to build node to property. And I think we don't need this. Right? That's all we need. Yeah. So I would say we will just test it and see what funny debugging things we will get. If name equals main, so the reader is blah blah blah. So path to file should be then data and then plate simple rigid.fem. Now we read it, we get modes, and then we build. Do we even have to do this? No, we don't really. Okay, so this is not really necessary. So that would be it. And yeah, let's just run it. For sure this will not work, but we will do then the Python, the debugging and see what's wrong. All right, starts with first argument must be a string, a tuple, or whatever. Oh, Isn't that enumerate of a dictionary gets you keys and values? So it IDs and okay. I think I missed that. Not sure. That's definitely not perfect here, but it works for now. So, empty dictionary. Great. What did we mess up? So, C triad 3 and C quad 4. So those happen to be here, right? Okay. Now, it goes through every line. Now let's just do a print line here. And I think, yeah, we will see. It doesn't go even in here. That's strange. I think I messed it up here, the file content. Yeah, I think I missed that. I think this is the correct one. Yeah, let's do it like this. Because I think read just puts it into one giant string. Yeah, alright. Oh, and I messed that up too. So it's something like so. Did I mess that up here too? Yes. Line, it's re sub, and then the line is a parameter here. Okay. On we go. List has no attribute split. What? Ah, I split it already. Okay, okay. Then let's not do it here. Split it here, but then it... that's not good. No. Let's split it once and just remove the split operation here. Okay. Okay, run it again. Yes, exactly. This is how we do it. So, line starts with... Huh, I didn't get that. It also said it would not be a string. Huh. What? Wait a second, I have to do it once more. Didn't get that. So, list object has no object starts with. Why is this a list? So for line in file contents. So this is not a list. Yeah, exactly. Do I have a really big lag? Because I fixed that, I think, 4 minutes ago or so to read lines. That could also be a lag. Read lines reads it into having a list of lines rather than having one giant read, because you then have to split by a new line character. So I don't get it. So here line is C quad. What the hell? Something happened here. Yeah, I redefined line, so that's not a good thing. But if I redefined line, the next one would be okay, no, that's not good. So let's do that with line content. And then switch that out for line content. And I think we don't need a print statement here. And that's it. Yeah, always be careful about okay, I see. The read is just a method here. This is called, however, it uses the read lines here. And yeah, so but yeah, you're correct. Let's correct that. Let's name it read lines. That's better. But it uses the read lines here. Okay, now we got a dictionary back, and it gets us ones and twos, so that's not so bad, not so bad. Now, what we would like to do now is to generate the RBE3 or RBE2 elements. Yeah. Okay, now let's see. If the line starts with RBE2, so now we have to think about this plus, because now we are exactly at here, at the component. Let's just continue to read in until it does not start with a plus. So that means we have to maybe fix a bit of how we're doing here, the things, because maybe it's easier. It's easier to do it like this. Line is E, so if it now starts with RBE2, why line? Okay, line equals the next line, right? let's do it like this. But if I just would have to have two RBE2 elements directly following each other in the file, then I think this would not work. Let's just make a line 2. So if line 2 starts, or let's do while line 2 starts with plus, blah blah blah, line 2, we split it again like this. That makes sense. Then we put the nodes here. So just think about it. Initially it does a line 2 and goes to the next line. If this is not the case, it will jump right up here and just follow with the next line. So this makes sense. If it's really like this, then I would say that I increase the line. And then I do my stuff here, and then I do also this again. Well, let's just think about this. Nothing plus 1. No. So just think about it. So with line 2, I go to the next line. So I'm actually with going here, I'm in the next line. I'm here. Then I ask if this line starts with a plus. If that's the case, I'm in the while loop. If that's not the case, because you could also think about something like have a RBE2 and then some data, yeah, and then another RBE2, because then I would not be in the while loop, and I would like to go back and increase the counter once and go to the line, right? So if that's the case for something like this, I'm not entering this while loop. So I just, this line 2 has no meaning at all, just to skip that while loop. And it goes up here, increases I, and goes to the next line. So that should work fine. Now, if I'm having a plus here, then it's different. Now I'm entering it. I increase the I because I did not increase I here. I just said, get me the next, the one bigger than I, get me that line, but I did not increase I. So if I jump after that, if I just would have one line, I would add my nodes. My line 2 would be the next line then, and then I jump out of the while, go up here, and then my line, which takes the ith element, will not be the next line, right? So this is why I increase the I, because now I know next time I should not start with the plus. Now I get this line, which I have here, add the node IDs, then get to the next thing here. Maybe it makes more sense to put that down here, because it's just a little bit easier to understand. But it has to be before this one. And it will loop and increase I as long as it is starting with plus. Yeah, that makes sense, I think. And then, when this is finished all, it does a rigid element. But this is not a good thing. No, no, no. The rigid elements should be something which is a list, but a list of MPC. Does that make sense? Does that make sense? Yes. So it creates an instance of, but I want to have an RB2 here. Or is it called rigid? How's it called? RB2. Yeah, I should rather import RBE2 as rigid. Yeah, no, no. All right, RBE2. RB2, and we have the element ID, the reference node, and the nodes. I don't really care about the reference node, to be honest. How is it here? So initialize self ID reference node nodes. Yeah. And I don't know about this. Here's the DOFs ID nodes. Let's do it like, oh man, I have to redesign it. This is so stupid here. So the MPC has the DOFs. Why can't it just super it? Because I think that's fine. Yeah, let's just make it like this. So in this case, the DOFs. It's not good. No, it's not good. No. Let's make it differently. So I have a DOFs here, which is a string. The nodes would be a list of string. And the ID would be normally an integer. Yeah. All right, there's a lot of there's a lot of refactoring going on here, or has to be done in the future. So I also don't need that string representation. Really, that's not a thing which has to be done. Okay, so we have IDs, nodes, and the DOFs. So here, the DOF would be a string. So this is bollocks. So this would be a DOFs. So the super would initialize with the ID nodes and DOFs. So that would make sense. And I think we can go with that. Now, here initialization, element ID, don't care about the reference node. Yeah, the DOF. Let's see what this is. No. The DOF is... So 1 would be that, 2 would be the reference node, which we don't care about, and 3 would be the DOF. So the DOF would be 3. Or DOFs. Something like this. Okay, let's think about it again. So here we're creating the RB2 element with the element ID, the nodes, and the DOFs. So that's a good thing. So let's reader.get rigid elements. And now for rigid element in rigid elements, blah blah blah, print forces. Now if that works, my name is Hans. No, this is not working, definitely not. But we will be debugging that, and it makes sense from the structure here. But yeah, we will still have to do the debugging because that's not straightforward. Let's see where it gets us. So, no module named MPC Forces tools. Did I rename that? I think we have to do the init.py. Here as well, and just to be sure, make it here as well. Now let's try that again. Okay, I see. Cannot do that here. Now, let's shift that. Let's shift that to the main function here. And let's do the import thing. Doesn't work. Yeah, that's also stupid, right? What else does it need here? It doesn't really need anything else. So it's on the top level and it's just going down. Okay, that makes sense, but I still think this will not work here. Because that's still the same thing, same mistake, right? Okay, let's start it again. See if it's working. No module named MPC. Am I stupid? MPC Forces underscore tools. What? So the main function is inside MPC Forces tools. That makes sense, right? Now we have a data structure. Oh, and somewhere it did not copy it here. Maybe that was the problem all along. And it would have worked fine just after doing that. Now, no module named MPC Forces underscore tools. Yeah, so this is where I would like to switch to poetry, to be honest. Why is it not working? So let's see that. MPC Forces tools is that one. Then we have reader, then we have model readers, and then we would like to have the FEM file reader. Why isn't it working? It's in code here. Maybe we have to change directory to go to MPC. Now, and let's run it from here. What? Same mistake. Huh. Module not found. Do I have to really do the /m? No. Ah, okay, now it works. Hey man, that's stupid. Why the hell does I have to do it this way? Yeah, okay, but if I'm here, this works, but I cannot get it to work with just a standard run, right? I would have to edit, I think, the run configuration or something like this. Yeah, I'm not sure about this. Let's maybe just do it with let's just do it with the standard way here. So we are in code and then we just run it like so. Python -m MPC Forces underscore tools .main. So now it says MPC is not defined. So okay, that makes sense. So that's an RB2. Yeah, rather it would be an MPC, to be honest. Okay, let's run it again. List out of range. So where is this? Line 3. Line starts with RBE2. That cannot be. Really? Let's print the line. Let's print a line. I want to see that. Ah, yeah. Alright. We changed it here. Yeah, sure. So that's not original data. So that was the problem. Now, key error. 1, 2, 3, 4, 5, 6. So this is not really a node. For node and self nodes. So there's something going wrong even before. So the line should have the dovs to be at 3. 1 to 3. Yeah, nodes should be coming after that, right? So I think that was the problem. What's now the problem? RB2 object has no there's something with a variable which is not matching. So that was just a typo. Now, key error 0.0. Where's the key error? Yeah, I think now we have to debug it really. It says key error 0.0. So the node would be 0.0. That's not that. Ah, okay. The last thing cannot be added. Let's see it. This is this one. How to do this? We remove everything which has a dot in it. Makes sense, right? Let's just remove everything with which has a dot in it. Those are the weights. Okay, let's do it again. Now we have another typo error. The reader does not have a node to property. Let's see. What should we get here? Node to force. Ah, yeah, we didn't even do that. Okay. Yeah, we cannot get a full program to run because we did not have the force data read in. So this should be something which we still have to do. Node to forces. Node to forces. Let's just make another reader for it. So a new reader. This would be the MPC Forces reader. Now let's first define a few variables. That would be, I think we can copy that from the other reader, from the model reader. What should we do? So file path and content would be good thing. And then let's also copy that one. All right, so that makes sense. But now here I think nodes to forces. I think that's, and this is not a list. This is a dict. Let's also get our typing straight. All right. Now we have this. The next thing we would like to do is to read just the thing here. Read lines. Yeah, that makes sense. Hey, great job on the encoding. Then get node to forces. So that also makes sense. Yeah, let's see what this is. No, that's not correct. So this is starting with this is even a little more complicated. I think we can safely assume that it is starting with line 12, because I think this should be the thing here. Yeah, but let's make it different. Let's just make it like so. For line in self-line content. No, that's not good. Let's do it for I equals in range of whatever. Yeah, then line is that, and if line contains, no, that's different than x force in line. E plus equals 2. So we go, yeah. So let's do it like this. So while it's not starting with the dashes, so I want to have the line here, line equals. So I go 2 lines down, then I get a line again in, then while it's not starting with whatever, now I'm not sure about this. So 1 down, and then I'm here, and then I'm here. So I go to the next line. So now this one. Now line content equals. So we need a thing again. Import rare. So rare sub whatever. So same thing here. Line content. Then node ID is the first thing. Then force is a list of the first 3. Yes. Great. Then, if that's not in there, put it in there. I don't want to have that in plus. So that should not never happen, right? So if the node is not in the node to forces dictionary, then it puts it in there, and it puts just the complete force here. And else, I will just print out a statement. This should not happen. All right, so this is this. So we can now go to the main and import the MPC Forces tools reader. No, I want a different reader. Okay. Is this already MPC F? Is this already going here? So data plate simple widget MPC F, and then it initializes this thing. It should also do the self.readlines. But if I do this, then I should make this a private. Do it a private? Is it like so? I hope so, yeah. So read lines, and the content is there, and the get nodes to forces should work then too. And yeah, then it should definitely return the dictionary, right? So once all this is done, return self.node2forces, yeah. Alright, main. Now we have this one. This should then work, and then we have this one, and this being inputted then here, and then the forces should be printed. Now, what funny debug messages we will be getting now is the question. So, yeah, sorry, that was the wrong command. I have to do Python -m. I have to do poetry at one point. MPC Forces tools.main. Okay, could not convert string to float. Empty string. Line content 1, 2, 3. Okay, we maybe have to print the line here, that we see what this is talking about. Now let's see again. So it was just an empty. What? I'm in the MPC Forces reader. What? Huh? I think it went just on and on and on, and we have this line here. But why only this one? Okay, we will have to see about this, but okay. Something like this. Empty lines, we don't want empty lines. Okay, let's see. Still have it. So print line is just an empty line. Why is it? So we are in here. Huh? Okay, let's see. Let's see. Yeah, okay, I see. This doesn't make any sense here. Because I have the line redefined here. So if it starts that's stupid. That's so stupid, man. All right, so let's add 2 here, then let's do our whole shenanigans here, and then let's increase the counter at the bottom. So that makes a lot more sense. Now, if the line starts with this is already covered, and then I think also yeah, that also does not make any sense. Yeah, so here it gets the line. Does that make sense to do it here? Yeah, because of this one. Yeah, okay, let's include that all again. Line strip equals empty line. So hopefully now it will catch that. Okay. Now, could not convert string to float. A result. What? Okay, where is it? Still here. So the line content is line split. Okay, I have to print a line here to see what's going on. Cannot even see that there's a result in the file. So, OptiStruct result 2023. Why the hell is it even in? Ah, okay, I see, I see. All this thing here has to be indented once. Because this is all here. Now, if I have X-force here, then it should work. Key error 401. Now we're getting somewhere. The thing is, 401 doesn't seem to be in the... why isn't it there? Okay, 401 seems to not be in the node to force. Okay, maybe let's do a debug. Where should we do the debug? Let's do a print, because I cannot really debug here because I have to start it with the package thing here. But this is an empty dictionary, so this is certainly there's something going on wrong here. So node to forces is empty. And this I don't know why. But I also have this, if X forces in line, then I have the print line here, but it never prints anything. So why not? Why not? So let's print a line here too, because I think it starts with the dashes. No. It doesn't do anything. Doesn't do anything. Let's do it like this. So we have the full file. What? Ah, okay. I see. That's the problem here. That's the problem. Okay, now I think we can skip that again. See now. Ah. Could not convert string to float. Yeah, now I think I know where we are. We are where we have this shitty thing here. And we have to deal with that sometime later, but I don't have too much time left, so I will just cheat here and delete this. This has to be done at a future point in time. Sorry, yeah, I have to choose that one here. Note already in dictionary should never happen. Ha, still have the same old data, but I changed it and saved it. Oh, I see. I did not save it. Did not save it in here. So this is the problem. All right. That we. Okay. Now it still has cannot convert to float line content. I have print line here, and the print is this one. Yeah, the problem is. Ah, that's so stupid to do it like this. So the line here is arbitrary because I have to increment here the I, and then line is not what it should be. So I would say self.file content I. I think that's more appropriate. Yeah, there has to be refactoring going on here. So you see that's just messy code right now. Okay. Now we have actually some things here. So we have some values here. And then we have a key error of 401. I'm not sure why this is a key error. So this should be forces, right? I'm not 100% sure why the keys. So the node ID. This is line content 0, right? Nodes to forces. So the node ID equals force if it's not there. Some messy code here, to be honest. So I split it by space, and then this one, yes, split it. This is the line content. Node ID would be the first thing. So looking at that, that would be this one. And we have always spaces here. There's nothing without a space. So 1, 2, 3 should also then be 1, 2, 3 here. So that makes sense. Now the force is there, and if it's not there, if this ID is not there, this get node to forces is also just executed once. Because the thing is, now in main, if I print the node to forces, this is exactly what I get here. And if I see what I have here is an empty string. An empty string. Why the hell is there an empty string? Does it start? It starts with a. Man, it starts with a. Okay. So, to do this, how should I do this? So I think we always do the strip line here. I see now, Alex. You're talking about every 8th character you have the split, and then you would have a better way of dealing with this one. So if I go 1, 2, 3, 4, 5, 6, 7, 8, this is the first, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. So there's different lengths. So 15, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. No, 14. Because the minus is always there. So it's like this. That's 13. And here, there's also 13. And here, there's also 13. So you have to think about where to. So the first one is 8. And then if I just do something like this, 8, 13, 13, 13. That's that. Yeah, you're right. So that could be an improvement. For yeah, that could be an improvement, and also dealing with the empty values there. So if it's empty, then just assume 0. That could be a better thing than doing it like this. You're right. You're right. But let me just try it if it's now working with the strip, because then I have peace at mind that it's not completely wrong what I did here. And then we can implement the other thing. Yes, I did mean strip. Sorry, strip was not good. Strip. Huh? Where's it? Now I think it makes a lot more sense now. We still have a node, which is an empty string. That's now a different problem. That's a different problem. So when I generate the widget elements, something like this. Yes. Yes, I think now we have a working solution. Let me tidy up and then we will improve it. But first thing, let's get the debug statements out. So print forces is what I'm interested in. And the MPC forces, there I have also a few of the print line statements here. Yeah. Okay, there's still one in the RBE2, so that must be here. All right. Okay, it took us a while, but now we have a dictionary which has 500 or minus 500 here and zeros there. I don't know why it has zeros here for the moments maybe, but I did not account for that. And then it has also 500 there. And so one thing done. Now let's improve that. Yeah, you're right with the MPC Forces reader that I should do that better. So let's make it differently. Take the first 8 characters as a node ID. So that would be that. Take the next, I think 12. Let's see. So if I have 8 characters, that would be here. And then from here to here should be selected 13. And that is now always 13, I hope. Yeah, 13. And let's just check the last one. That goes from here to here. 13. 13. Oh, that's so stupid now. I cannot make that better. You have suggested something, right? Let's just copy that in here. From I to I plus 1 for I in range 0 to length of line, and then n is... Yeah, but this is just working for the second batch then, right? For the first batch it's not working. So I should do something like 8 plus here? Not sure so much about it. Let's just try to use... Yeah, it's the same thing, right? Ah, yeah. I plus n. That's the same thing you also suggested. In range 8 to length of line. Yeah, so I think this is the same solution you did. So n is there, then we can do... Yeah, exactly. You also suggested it now. Yeah, great. So now we have that. Force X. Yeah, exactly. That's what I'm looking for. Now some error corrections. So if it's not empty string, else I would say it's 0. All right, so this is this one. And then we can say force equals and then just have that. Yeah, something like this. Let's see. Oh, something did not work. We're still missing here something. So n is 13, so that makes sense, right? Let's just print line content and see what it is. Oh man, what did I do here? Ah, God. Sorry, I have to. So, line content. So it went on from 2406 plus 1 plus 0, 1, and then 3, 4. So it messed up the starting. Maybe I should not strip it. I think that's the problem. Yeah, I should not strip it for that one. This could be... Yeah, this could be working. Yes, now we got it. And now let's just think of if there was something like before, right? I'm not sure about. I will just run it again, the model, because it doesn't take too long. Because I don't know the ID and I have to get the ID right. Because if the ID is not correct, then it will get a failure, different kind of level. So just run this once and then get the data again. So this would be the MPC Forces. And do that again in the data here. Something like this. And now let's run it again. I think then I will also call it a day. Ah, okay. It did not work. Could not convert string to float. Yeah, okay. Then we would make something like... Does it make sense to do a line strip here? Cannot type anymore. Let's see. No. Yeah, well, it makes the correct thing, right? But the strip did not work. The strip did not work. Line I blah 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 for I in range. Yeah, let's just make a simple solution. So for I, yes. We strip it away, then we have empty strings here, and then it should be okay. What? Okay, I will have to have the line content again. What? CE real. Huh? What? The only real I see is here. Ah yeah, here. Why is it going... Huh? It's going in here. If X force in line. Huh? Ah, okay. Yeah, I don't have to have the die here. Let's use another temporary variable. Yeah, that's an important case why it's so important to have also linters. Yeah, now it works. All right, so what happened there is what I did redefine I, and so it jumped all over the place and went to a different line, and then in the next loop it did not work out very well. So there's a lot of things to be done. Debugging here, doing documentations, adding poetry for dependency management, a lot of stuff. But nothing I could do today. If this is something which interests you and I should continue doing more, I would be more than happy to do so. Just leave a comment, a like, and subscribe to the channel that you don't miss it. And yeah, you could also just write me a mail with feature requests or something like that. I most certainly will upload this to GitHub as in a point on the future. Not sure when. Maybe when it's in a somewhat decent state. And yeah, we will continue to develop something like this. And yeah, thanks for being here. Yeah, coffee breaks are desperately needed. Yeah, I have to go to the to fitness now. Been neglecting that. Yeah, same thing. Thanks, Alex, for contributing to chat and also for helping me out with the splitting of the line. So that was appreciated. And yeah, so if there's anything else we should see or yeah research here, just let me know. In the meantime, have a good day, everybody, and yeah, see you next time. Bye, guys.